Alright, hello everyone. So this question is asking us to identify the orbitals used to form the bonds and the bond angles in H2CS. Now here we have 4 different answer choices labeled A through D, proposing not only the different types of orbitals, but different values for bond angles, including 90 degrees, 120 degrees, or 109.5 degrees. So let's start with the Lewis structure of our given here, which is H2CS. Otherwise known as thioformaldehyde. Recall that when it comes to drawing the Lewis structure of any given molecule, the atom with the highest bond preference should be in the middle. Carbon has a bond preference of 4, sulfur has a bond preference of 2, and hydrogen has a bond preference of 1. So carbon should be in the center, and sulfur as well as both hydrogens should be on the outside. Now, hydrogen obeys the duet rule, which means that only 2 electrons and therefore 1 covalent bond is preferred for it. Because of this, there should be a double bond in between carbon and each hydrogen. This leaves us with sulfur. Now, sulfur has a bond preference of 2, and carbon is the only atom available to bond with it. So a double bond in between carbon and sulfur is going to fulfill sulfur's bond preference. But is the octet rule obeyed? Because carbon and sulfur strictly obey the octet rule, which means that it would rather have 8 electrons in its outer shell. Now, sulfur does prefer to have a full octet despite having a bond preference of 2. This means that the remaining 4 electrons are present on sulfur as 2 lone pairs. And now we've completed our Lewis structure. So now let's talk about hybridization. Hybridization is best determined by understanding the total number of quote-unquote groups surrounding a given atom. There are 2 different types of groups for the sake of this discussion. We have electron pairs and any other atoms connecting to the atom of interest. Let's take carbon for example. Carbon has 0 electron pairs, but it has 3 atoms surrounding it. So the total number of groups around carbon is equal to 3, which therefore corresponds to sp2 hybridization. Moving on to sulfur. Sulfur has 2 lone pairs of electrons and only 1 other atom directly connecting to it. That makes a total of 3 once again, which corresponds to sp2 hybridization. And hydrogen is unique in that it can only use an s orbital for bonding. So when it comes to the orbitals used for bonding, we have the sp2 orbital of carbon and the s orbitals of both hydrogens, as well as both sp2 hybridized orbitals, or sp2 orbitals I should say, for the carbon and sulfur double bond. But because it is a double bond, an sp2 hybridized orbital always has one p to p overlap to form the pi bond. So with this in mind, let's go ahead and talk about bond angles. Because the hybridization of the central carbon is sp2, and carbon has 3 groups surrounding it with no lone pairs of electrons, its geometry is trigonal planar. And because it's trigonal planar, all bond angles around carbon would be 120 degrees. And so with that being said, our answer is option C in the multiple choice. As for the orbitals, we have the CsP2 to HS, the CsP2 to SsP2, and the Cp to Sp. In addition to that, all bond angles are 120 degrees. And there you have it. So with that being said, thank you so very much for watching, and I hope you found this helpful.